In applied algebra problem number 6, we're given a common scenario where we're not looking for a numerical answer. We just want to rewrite an equation in terms of a variable that we'll need to find a lot in the future. For example, we have this volume of a cylinder formula, and it's very common to want to determine a radius based off a given volume and height rather than determining the volume. So if I'm going to do this a lot, then I could just develop the equation in terms of radius and then write that on a sticky note somewhere for my reference. So let's get started. We need to find this r right here, which is deeply embedded into this volume of a cylinder equation. We'll start out by writing the equation as it is. Volume equals pi r squared times height. First thing we'll do is divide both sides by pi and the height. Pi's will cancel out on the right side, the height will cancel out on the right side, so that we're left with v over pi h equals r squared. And now to get rid of an exponent, we do the opposite of an exponent, which for r squared, that's going to be taking the square root of both sides. Another way to represent this, and a way that's very common for working with exponents of a power different than 2, is to write it in terms of its exponent reciprocal. So to take the exponent up to the half, we'll get rid of power of 2. It's just like with reciprocal fractions. 2 times 1 over 2 is going to equal 1. So our equation now is, and I'll just write it as a square root now, it's going to be r equals the square root of v over pi h.